Welcome. In this lecture, we shall relate various parameters mathematically in the analysis of beams, namely rate of loading, shear force, bending moment, slope, and deflection for any cross-section along a beam's length. It is known in the chapter of shear force and bending moment in beams that the shear force at any section along a beam's length is actually the rate of change of bending moment with respect to the length, and also that the loading is the rate of change of shear force with respect to the length. In the differential equation of the elastic curve, we learned that the derivative of the deflection with respect to the length is the slope, and the derivative of the slope with respect to the length is proportional to the bending moment. We can hence combine all these parameters so that all can be expressed as a function of the deflection y and its derivatives. A table can be formed as follows, relating the various parameters. We start off with the deflection denoted by y at a given section of the beam at the lower end of the table. The first derivative with respect to the length gives us the slope at this section denoted by symbol theta and measured in angle radians. The bending moment at a section is equal to the flexural rigidity EI times the derivative of slope, that is, the double derivative of deflection with respect to the length, as per the differential equation of elastic curve. From the theory covered in shear force and bending moment in beams, the shear force is the derivative of bending moment with respect to the length and hence proportional to the third derivative of the deflection at the section with respect to the length. Further, the loading is given by the derivative of shear force or the fourth derivative of the deflection with respect to the length at a section. From this table, it is clear that the derivative order increases as we go in a direction from the deflection to the loading. Alternatively, the integration is performed consecutively as we move in a direction from the loading to the deflection. It can be noted from the loading parameter that all the terms can be taken on one side of the equation, which gives us a value of 0, which is nothing but a differential equation denoting a force balance or static equilibrium of the forces acting on the beam at some differential length. This shall be a starting point in the analysis of beams using a numerical technique called the finite element analysis, which is the subject of study for a future course. In the next lecture, we shall look into some examples of beams with simple loading for finding slope and deflection equations solved initially by the double integration method.